So in this particular video, we are going to discuss something related to input-output ports, timers, and serial communication section of the microcontroller. Okay, so we know what is meant by a port. Port is nothing but a register. Port is nothing but a register. So we already had a discussion related to various blocks of this microcontroller. Just have a glance at this particular block diagram. So in this port 0, port 1, port 2, port 3, these are the registers. Port is nothing but a register used to access the data. If you want to send the data from microcontroller to the outside world, or if you want to take the data into the microcontroller, we use port 0, or you may use port 1 or port 2 or port 3. So in that context, it is important for us to know what is the port and how to work with that particular port. Okay, input output ports. So microcontroller comes with 4 ports. In some microcontrollers, you may see only 2 ports. In some, maybe 3 ports or 4 ports, 5 ports. Depends on the type of the microcontroller that you are selecting. Okay, so the 4 8-bit ports will be available to this present 8051 microcontroller, which can be used as input ports as well as the output ports. So upon resetting the microcontroller, all these ports are configured as input ports, ready to be used as input IO ports. Okay, when if you want to convert this particular port as input port, you have to put one on each and every bit in each every bit. So p naught dot 0 should be made high, p naught dot 1 should be made high, p naught 2 similarly 3, 4 and 5 and 6 and 7. So in order to configure this particular port as input port, and if you put 0 on this, if you clear p0 dot 0 and p0 dot 1 2 3 4 5 and 6 and 7, this entire port works like entire port works like output ports. So it can be used as input port or else output port. To use one port as input port, so each and every pin should be made high. So in order to use that particular pin, our entire port should be made high in order to use that particular port as input port. Each pin must be connected to externally pull-up resistors. So these resistors are called as pull-up resistors. See, VCC is connected to VCC is connected to resistor, and the other end of the resistor is connected to P0 dot 0. Why? Because it is due to the fact that P naught is open drain. As I told you, that microcontroller is manufactured using n-channel metal oxide field effect transistor. So this is what is the gate, and this is source, and this is what is drain. So drain is open. So this is due to the fact that P naught is open drain, open drain. So but for the remaining ports like P1, P2, and P3, so they are not open drain. They are not open drain, right? Ports. So that's why it is essential for us to connect a pull-up resistor, pull-up resistors. Okay, when you're using port 0 as input port or else an output port, right? So we'll move to the next one. So the essence of this particular slide is microcontroller comes with the 4 IO ports. The length of each port is 8 bits. 4 8s, 32 IO pins will be there to the microcontroller in order to receive the data or to send the data to the outside world. Upon reset, all these pins works like input pins, or means all ports work like input ports. And so in spite of that, if you want to configure a port as input port, okay, each and every pin should be made high made high to use that particular pin as input pin. And to use that particular port, you no need to specify, or you no need to put zero specially. But if you put zero on the port, it works like output port. So, okay, port zero should be connected to a pull-up resistors. So because that is open drain means each pin is connected to open drain field effect transistor. It means the drain is open circuited. So like P1, P2 and P3, they are not open drain. Means their FETs are not open, drains are not open, right? So now similarly, port 0 is also designed designated as, means each port apart from working like input output port, some port behaves like dual ports in the sense, apart from working like input output ports, port 0 works like address lower order address bus as well as low as data bus. AD0 means lower order address bus. AD0 to AD7 is lower order address bus. The same bus works like data bus also, allowing it to be used for both address and data. In order to make port 0 an input port, the port must be programmed by writing 1 to all its bits. Okay, so similarly, port 1 can be used as input output ports in contrast to port 0. Just like port 0, you don't need to connect any pull-up resistor. Okay, pull-up resistors, right? And to make port 1 an open port or input port, it must be programmed as such by writing 1 to all the bits. Means you have to make P1.0 equal to 1, P1.1 equal to 1, P1.2 is equal to 1, P1.3, 4, 5, 6 all equal to 1. Then only that entire port works like input port. Now coming to P, you can see here P0.0 is the same, works like AD0 also. AD0 means address data pin. AD1 address data pin 1. AD2 address data pin 2, 3, 4, 5, 6 and so this bus works like lower order address bus. The length of address bus in microcontroller 8051 is 16. 0 to 15 are 16 lines. So 0 to 7. So this bus is called as the lower order address bus. P2 works like higher order address bus. Apart from working like input output port, P2 port 2 works like higher order address bus. Okay, so you don't need to connect any pull-up resistor in order to configure. You don't need to connect any pull-up resistors like in port 0, right? Internally, they'll be having connection with the pull-up resistors internally for port 1, port 2, and port 3. Port 2, in order to use this port as input port, you have to write. You have to make each and every pin equal to 1. You have to set each and every pin. So such by writing ones to all its bits. And port 2 is also designated as A8 to A15, indicating the dual function. So this works, it's having dual nature. Whereas port 1 is not having any dual nature. This is the dedicated input output port. Whereas port 0, apart from input output, it behaves like address bus as well as the data bus. Now coming to this port 2, apart from working like input output port, it works like higher order address bus. Now coming to the port 3 can be used as input output ports. You don't need to connect any pull-up resistors. These will be available inside the microcontroller itself. Port 3 is configured as input output port reset. This is not the way, but generally we don't use port 3 like any other like any other port, as it's not meant for using. It's like input output port. But not like if there is a requirement, then you can use port 3 also as an input output port. Okay, but port 3 has an additional function of providing some external extremely important signals. See, you can see here port 3.0 works like receiving pin during serial communication. P3.1 transmission pin. If you want to transmit the data serially one bit after the other and receive one bit after the other, so then P3.0 and P3.1 are essential. The data goes out, comes in through these two pins. Now P3.2 and P3.3, so these are external interrupt pins, INT0 bar, INT1 bar. So these two are external interrupts pins. Okay, P3.4 and P3.5 works like timer pins. Timer is nothing but a circuit which supplies the clock signals, the timing signals required for other circuits. Let us suppose you take a counter. A counter is an electronic circuit which counts the clock pulses. In order to count, you need to apply the clock pulses. So you have to apply the clock pulse to the counter, then only it will count. Okay, if you don't apply the clock pulses, it won't count. So timer is the one which supplies the clock pulses and timing pulses or timing signals. T0 and T1 are the timers. So if you want to, there are two 16-bit timers are there in 8051 microcontroller. So one uses this pin, the other one uses P3.5. And read bar and write bar. If the microcontroller is performing some read operation, maybe write operation. So IO read, IO write. It may be writing something on the output device. It may be writing something or reading from some input device. So during those two operations, these two pins will be considered by the microcontroller. Read or write signals of external memory. Okay, so port 0, port 1, port 2, port 3 are the four ports. All these port works like input output ports apart from working like input output ports, except port 1, remaining all the ports like P0, P2 and P3 works means they work for they do the other work also, means dual work will be there. Apart from working like an input output port, P0 works like lower order address bus as well as the data bus. P2 port 2 works like higher order address bus. Combining port 0 and port 2, that entire port works like that entire thing works like those 16 lines work like address lines. And port 3, additional function of the providing some extremely important signal. Two pins are for serial communication, two pins are interrupts, two pins are timer pins, and two pins are external read or write signals. So these are meant for this. So you may get an essay question or sorry, you may get a short answer question. Explain the functionality of port 3. Okay, write short notes on port 3. Right. So then we'll go to the next one, stack and stack pointer. Stack and stack pointer. Stack is nothing but it's a part of RAM. The stack is a section of RAM used by the CPU to store information temporarily. User also can store the data temporarily in that, not only CPU. This information could be data or the address. So, and we use stack pointer register, which is an 8-bit register in 8051. Okay, which is an 8-bit register in 8051. So which holds the top address of the stack. It holds the top address of the stack. We use two operations. One is push, the other one is pop. Push is the instruction to push the contents into the stack. You want to store something in the stack, then we use this push operation. If you want to retrieve something, if you want to take the data from stack, then we use an instruction called as pop. Okay, pop. Okay, SP is pointing to the last used location of the stack. If you push, as we push the data onto the stack pointer will be incremented by 1. If you pop it, then the stack pointer is decremented by 1. It will be decremented by 1. So pop and the stack pointer is decremented. So this is decremented. Word is cut in the yeah. The pointer is decremented. So means push means incremented. Pop is decremented. So means if you push the contents into the stack pointer will be incremented, and when you pop to that, then the stack pointer will be decremented. All right. So move R6. See, this is what is the default stack address is going to be stack pointer location is a 07. Upon reset, the stack pointer will be loaded with 07. 07, right? So you just have a glance at this particular program. Move R6 comma hash 25. R6 will be loaded with 25 hexadecimal number. R1 is loaded with 12. R4 is loaded with F3. Push 6. Push 6 means push the contents available in R6. Push the R6 content into the stack. What is there in R6? 25. So stack pointer will be incremented by 1. It will become 8. So the content available in R6, that is 25, will go into this 8th location. Now what is there in the stack pointer? Okay, that is 8. Now push 1. Push 1 means push the contents available in R1 into the stack. The stack pointer will be incremented by 1. Now the stack top address is 09. Whatever is there in R1, that is 12, that will come into that location. Now push R4. Push R4 means save the content available in R4 into the stack. So before pushing, the stack pointer will be incremented by 1. 9 will become 10. The top address of the stack is going to be 0A. So the content available in R4 register, that is F3, that will come into that location, that is 0A. So with this particular example, it is very clear that whenever you push something into the stack pointer will be incremented by 1. Whenever you pop means whenever you're trying to retrieve something from stack register, then the stack pointer will be decremented by 1. Right? The default when the microcontroller is powered up, the stack point register contains a value 07. So this is an important point. That's why it is highlighted. And stack pointer is a special function register which is not bit addressable. Now coming to the next one, SFR. SFR means special function registers. As I already told you, these can be accessed. These are meant to do special works. Special. That means the microcontroller uses these registers for specific purposes only. So these can be accessed by their names or by their addresses. Each of SFR will have one unique address. You can refer to that SFR special function register with their name or else with their address. Okay, a few are bit addressable, few are not bit addressable. ACC accumulator, which is bit addressable. Okay, bit addressable. B register is bit addressable. You can refer to B register with its name by BR0F0. PSW, program status word. The ones which are having stars are bit addressable. Not having stars, they are not bit addressable. They are not bit addressable. PSW is bit addressable. 0D0, which means that is program status word. This is what is the address of PSW. Just like a student may be having name and roll number. We can refer to that particular students with their name like PSW with a roll number, that is 0D0. Okay, stack pointer 81. Data pointer register. This is the register which will not have one dedicated address, but data pointer is a combination of two registers. One is data pointer higher and data pointer lower. Data pointer higher byte address is 83, 82. 82 means data pointer lower, 83 means data pointer higher. P0, port 0, 80, port 1, port 2, port 3, IP, interrupt priority control. Interrupt priority control is a register, which is a special function register. The address of that is B8, IE, interrupt enable control. So 0A8H. T mode, timer mode. You want to work with the timers. You want to generate the clock signals. So that time you have to use this timer mode register. Okay, the address of that is 89, which is not a bit addressable. TCON, timer control register 88. TCON, T2, TCON. Some microcontroller will have this. Some microcontrollers will not have these two. Okay, TH0, TL0, TH1, TL1, TH2, TL2. Okay, like that. Yeah, all these are SCON serial control. All these are special function register. SCON serial control, serial buffer. So we and power control. These three we use for serial communication. You can refer to them with their name like SCON register, like accumulator, SCON register, or with its address that is 98. Right? Now coming to the same thing here. The same thing here. So yes, buff register, it's not bit addressable. P2, P3, accumulator, B register, PSW, these are the bit addresses. So D0 is the least significant address. D1, D2, D3, D4, D5, D6, D7. D0 is the address of PSW. But if you want to refer to the least significant of PSW, you just have to use D0. D1 means PSW.1, D2 means PSW.2, D3 means PSW.3, D4 means PSW.4. So like that. So B, accumulator 0E0, 0E1, 0E2, 0E3, 0E4, 0E5, 0E6, 0E7. So these are the bit addresses. Okay. So few are not bit addressable, few are bit addressable. Whichever is bit addressable, that is given with bit addresses. This is 90. 90 is P1.0. 91 is P1.1. 92 is the address of P1.2. 93 is the address of P1.3, 4, 5, 6, and 7. P1 is a bit addressable register. That's why each bit address is given here. All right. So now coming to the next one, timer and counter. Timer and counter. Timer, the counter is one which counts the clock pulses. Timer is the one which generates the clock pulses. There is a separate section available inside the microcontroller which will do this timing action. It generates the clock pulses, which counts the clock pulses. There are two timers are available in this microcontroller. So one is T0, the other one is T1. Timers to generate the time delay are as event counter to count the number of events happening outside the microcontroller. Okay, and timer 0 and timer 1 both are 16-bit wide timers. So 16-bit timers. So you can see this is T0 and this is T1. T0 is divided into two parts. Okay, lower order 8 bits, that's called as TL0, higher order 8 bits are called as TH0. The lower order 8 bits of T1 is called as TL1, higher order 8 bits of T1 is called as TH1. All right, the low bytes of register is called as TL0 and TL1. High registers are called as TH0 and TH1. They're not bit addressable. Access like any other register. Just like accumulator, you can take the data from this, you can send the data from this. Okay, both T0 and T1 use the same registers. Use the same registers. And T mode is a register which is used to decide the mode. So what is meant by time or mode? That and all we discuss little more clearly. So in the third unit or during the timer programming, T mode as of now, T mode register is a register which is used to set various timer operations and modes of the timer section of the microcontroller. TCON register is to control the action of the timer. So what is meant by controlling? Stop the timer, stop the counter, start the counter, stop the counter. So these are the timer actions. So those can be controlled with the help of TCON register. The frequency of the timer is always 1/12 of the frequency of the crystal attached to the 8051, regardless of the 8051 version. So if you are taking 12 megahertz clock signal, 12 megahertz clock signal, if you're applying to the microcontroller, the timer clock frequency, the frequency of the timer is going to be 12 megahertz by 12, that is 1 megahertz. So means whatever the input signal frequency, that will be divided with 12. That is what is the meaning of this. We will have this discussion little more clearly during the timer programming. Okay, so as of now, timer and counters, there are two timers will be available. The length of each timer is 16 bit. T0, T1. T0 is a 16-bit register. T1 is a 16-bit register. It's divided into two parts. One is TL0, lower order T0, and TH0, higher order T0. TL1, lower order T1, TH1, higher order higher order T1. Okay, Tmod and Tcon registers are used to set the various timer mode operations or to control the timer and counter action of the timers and counters available inside the microcontroller. And coming to the serial data communication, microcontroller comes with serial communication UART. USART, Universal Synchronous Asynchronous Receiver and Transmitter. So you can send the data serially, you can receive the data serially. So the number of bits per second is called as baud rate. Baud rate. Serial data communication uses two methods. One is synchronous method and asynchronous method. Okay, synchronous method means the block of data. Means you want to send a huge amount of data, block of data at a time. So that is called a synchronous method. Asynchronous method means one bit after the other. After sending the first bit, then the second bit, then the third bit, like that. So in transmitting the data, microcontroller uses two registers. One is SBUF register, the other one is SCON register, others may be PCON register. Okay, SBUF, serial buffer register, serial control register. You want to start the serial communication, stop the serial communication. So that and all is possible with SCON. SBUF, whatever comes inside the microcontroller, that will go into SBUF register. Whatever you want to send to the outside world, that will go from SBUF register to the outside world. So PCON register it's used to set the data rates. Means 9,000 bits or 4,800 bits per second. Bits per second, how many bits that you want to send per second? That is called as baud rate. That is called as baud rate. Okay, BPS. It's also called as BPS or baud rate. Okay, so microcontroller will have two pins. One is RxD, receiving pin, TXD, transmission pin for serial data communication. So we'll have a detailed discussion of how to send the data serially, how to how to receive the data serially. That time we'll focus more on SBUF register, SCON register, PCON, TXD, and TRXD registers. So with this, the microcontroller architecture will come to an end. So not only this, there are some microcontrollers may be having many other features like analog to digital converters and image processors. So also will be available. Digital to analog converters will be there. So microcontroller in one single IC, all these things will be available are embedded inside that. So it may come with analog to digital converter, it may come with a digital to analog converter. Depending on your application, you have to select such microcontrollers. For that, you have to spend little more amount also. So if your application doesn't demand analog to digital converter and digital to analog converter, don't go for such microcontrollers. Confine only with microcontrollers having ports, timers, and serial communication networks. Okay, so thank you very much for your patience. Thank you. I'll stop it here itself.